right, welcome back. My name is Mr. Anderson. This is Chapter 2, Equations. First thing we're going to talk about is solving equations. In other words, getting x by itself. We're going to start with solving something like this. To solve equations, we use algebra. Essentially, algebra is all about getting rid of things you don't like until you get down to having x by itself and x equals some answer. If I look at this problem, I don't like the fact that there is that square root there. Square roots can be annoying and difficult to deal with. Luckily, I know how to get rid of square roots. I'm going to square both sides. However, when you square both sides, there is going to be a thing we need to pay real close attention to. First off, let's just talk about squaring them. I would not square both sides now. Right? Squaring both sides like that is going to be a pain. That would be 1 minus the square root of 2 minus x times another 1 minus the square root of 2 minus x, and that would not be one I want to actually multiply out. That's right. So first thing I would do is I would subtract 1 from both sides so I could get that square root by itself. So subtracting 1 from both sides, I'd have 2x minus 1 equals a negative square root of 2 minus x. Now, if that negative bothered you, multiply both sides by negative 1. It doesn't actually bother me though, because I know when I square it, a negative times a negative is a positive, that negative is going to go away. So I am going to square both sides at this point right here. However, whenever I square both sides, I keep in mind that I may be introducing a false answer. That type of answer is called an extraneous solution. I'm keeping that in mind because when you square both sides, you could take an equation that originally wasn't true and make it true. I'll give you an example. Let's say 3 is equal to negative 3. That's not a true statement. 3 is not equal to negative 3. But if I square both sides, all of a sudden I get 9 equal to 9, and I make a statement that was false, and I turn it into a true statement. So when I do that operation, I might be taking a statement that was false and making it into a true statement. I would be adding what's called an extraneous solution, a solution that's not actually true, that doesn't work. Most operations, I don't have to worry about that. If I had, let's go back to that 3 and negative 3. If I had 3 equal to negative 3, that's not a true statement. If I did something like multiply both sides by 2, I end up with 6 equal to negative 6, which is still not true, right? If I subtracted 1 from both sides, I would get 5 equals negative 7, which is still not true, right? I'm not going to suddenly make that a true statement by adding or subtracting something or by multiplying by a constant. But I could make it a true statement by squaring both sides. So if you ever square both sides, just keep in mind that, hey, we might be introducing a false solution, an extraneous solution, so we're going to have to check that later. I wouldn't let that stop you squaring from both sides, though, because it's definitely better than dealing with that square root. So squaring both sides, let's see, on the left-hand side, that'll be 4x squared minus 4x plus 1. On the right-hand side, a negative times a negative is a positive, so that's going to take care of that. And squaring that square root would just leave me with 2 minus x. This is a much easier problem to deal with. I would probably move everything to the left, set it equal to 0. So 4x squared minus 3x minus 1 equals 0. This is something that we can factor. If we couldn't factor it, we could use a quadratic formula. But in this case, that does factor. 4x plus 1 and x minus 1. I've got two possible solutions. From this factor, I've got a solution of x equals negative 1/4. And from this factor, I've got a solution of x equals 1. However, I'm going to check my answers again, especially because I squared both sides. I might be introducing an extraneous solution. Let's check the x equals 1 first. Let's take that 1 and plug it back in. Instead of a 2x, I'll have a 2 times 1 equal to a 1 minus square root of that, square root of 2 minus 1, right? Just plugging a 1 into my original equation. This will get me 2 on the left is equal to 1 minus the square root of 1, which is 2 equals 1 minus 1, which is 2 equals 0. That is definitely not true. X equals 1 is definitely not a solution. Since it's not a solution, it's called an extraneous solution. That x equals -1/4 solution, it would be a good idea to plug that in just to make sure it works, make sure you did your math right. In this case, I'm going to tell you it definitely will work. It'd be a good idea to try it yourself just to make sure, but that solution does work. Moving on. Problems like this sometimes get people because those fractional exponents can kind of seem tricky. One of the things to keep in mind, though, is another way to write this problem would be to write this like x to the 1/5 squared minus 4x to the 1/5 plus 3 equals 0. Being able to rewrite it like that can make this type of problem much easier, because you'll notice I've got something squared minus 4 times that same something plus 3 equals 0. We know how to factor things like that. I'm going to use a different variable. I'm just going to use an m. If I had m squared minus 4 times m plus 3 equals 0, we can factor that. That would factor into m minus 3 times m minus 1 equals 0. This thing here factors in the exact same way, right? Except the only difference is instead of having an m being squared and an m after that 4, I had an x to the 1/5. So it factors in the same way. It's just instead of an m minus 3, it's going to be an x to the 1/5 minus 3. And instead of an m minus 1, an x to the 1/5 minus 1. This line here can factor just the same way. Once you go that far, then it's easy. I've got two things multiplied together to be 0, so one of them has to be equal to 0. It might be this one on the left, in which case x to the 1/5 would be equal to 3. How are you going to get rid of that 1/5 power? Well, take both sides to the 5th power. X to the 1/5 all to the 5th would be x to the 5/5, which is just x. And 3 to the 5th, that's 243. This one, a lot easier. That'd be x to the 1/5 equals 1. Take both sides to the 5th power. 1 to the 5th power is still 1. All right. Roots. When we talk about roots of an equation, roots, x-intercepts, zeros, those are all essentially names for the same things. Roots of an equation are what you could plug in to make the equation equal to 0. So if I gave you a problem like that, in fact, was this similar to the other one? Almost exact. Instead of a minus, it's a plus. If I asked you to find the roots of y equals x squared plus 4x plus 3, it's really just asking, when does x squared plus 4x plus 3 equal 0? The roots would be what make them equal to 0. So it's an easy one for this. Factor it. X plus 3 times x plus 1 equal to 0. I get one root from this side of a -3 and one root from that factor of -1. All right, if we can do it one way, we can do it the other way. This problem is asking us to write a quadratic equation whose roots are these fun numbers. And then we're supposed to write our answer into ax squared plus bx plus c form, standard form. If I know the roots, I know that those are the zeros of the equation. So one easy way of doing this is to just write the equation in what's known as factored form. I would know one factor is x minus that first one, that r1 root, and the other factor is x minus that second one, the r2 root. Right. That's kind of a silly way to write it like this, so let's rewrite it into using the actual numbers. So it'd be x minus 3 plus the square root of 2, subtracting all of that, times x minus 3 minus the square root of 2. All right, let's simplify that thing out. This would be x minus 3 minus the square root of 2 times x minus 3 plus the square root of 2. Multiplying this out, x times x is x squared. X times -3 is minus 3x. X times the square root of 2 is plus square root of 2 times x. I like putting my x first just so it doesn't look like the x is inside that square root. So when I do -3 times x, that's -3x. Instead of writing minus 3x here, I'm going to put it with my other x term, minus 3x right there. So they're easy to combine. -3 times -3, that's a positive 9. I don't have any constant term yet, so I'm going to throw that over here, positive 9. -3 times square root of 2, that's -3 square root of 2. I don't have any of those terms, I'm going to write over here, minus 3 square root of 2. All right, and then the last terms, negative square root of 2 times each of those. Negative square root of 2 times x would be negative square root of 2 times an x, or put the x first. I'm going to put it right here, because those terms are going to work out real nicely together. Negative square root of 2 times a -3, well, a negative times a negative is a positive, so that'd be positive 3 times the square root of 2. I'm going to write that right here. And negative square root of 2 times the square root of 2, well, square root of 2 times square root of 2 is 4. One of them is negative, so a -4. I'm going to write them right there. There's a single x squared minus 6x's. Those cancel out. And plus 9 minus 4 ends up being the plus 5, and those terms cancel out. And there's my equation. All right, let's finish this thing up. Inequalities. Inequalities, same type of thing, except instead of an equal sign, there's an inequality sign, right? Here we're asked to solve the inequality. It's just like anything else. You get rid of what you don't like, try to get x by itself. In this case, I don't like that plus 1, so I'm going to subtract 1 from all sides of the equation. -3 minus 1 is -4. That'd be less than 2x, which would be less than 8. Divide everything by 2, and I'll get -2 is less than x, which is less than 4. That's all there is to it. Get x by itself. X is trapped between -2 and 4. This problem did ask to write my answer in interval notation. This is not interval notation, that's inequality notation. So my answer in interval notation would be all the numbers from -2 to 4. Oops, I lost my equal sign. Notice how this was less than or equal to, and I just wrote it as less than. That wasn't good. That should be less than or equal to, right? So -2 to 4, not including -2, so parentheses there. Yes, including 4, so bracket there. What if you're asked to solve something like this? This is going to be an important one, so we got to talk about something before we do. There are two instances when the value of a function can switch signs, i.e. when a negative can become a positive number or the other way around. One way is for the function to cross the x-axis. If I had a negative value and I wanted to be positive, one way I could do that is I could cross that axis, and as soon as I cross that axis, then I've got positive values. And maybe I cross it again, and I've got negative values, right? So I can cross the x-axis, and I can go switch from a positive value to a negative value. The other way I could do it is I could have a negative value, and I could have a function briefly become undefined. It could be traveling around here, and then maybe there's an asymptote, and it suddenly switches to that, right? Now it's up here, positive numbers. Or maybe there is a brief time where it does a discontinuity, and it jumps down here, and now it's a negative value. All right, where we see that in equations is like this. If this thing is less than or equal to 0, if the numerator is equal to 0, I'll have 0 divided by something, and 0 divided by something, like 0 divided by 8, that's equal to 0. That's an opportunity where I could cross the x-axis. If the denominator is equal to 0, I'm not equal to 0, right? If I had 8 divided by 0, that's an undefined number. But that's also an opportunity for my function to cross the axis. So I'm not sure what this equation looks like, but I know two things about it. I know it's equal to 0 at -5, and it's undefined at 4. So those are the only two spots where my function could have crossed the axis. So the way we're going to solve something like this is we're going to use what's called a sign chart. I'm going to put those two important values down on my sign chart. One of them at -5. I'm going to put a closed circle on there, because that's where I'm equal to 0. And one's at 4, and I'm going to put an open circle on 4, because I'm undefined at 4. I'm not actually equal to 0. And I'm just going to test some values. If I test something over here, something more negative than -5, like let's say -10, If I put a negative 10 into that equation, I'll have negative 10 plus 5 over negative 10 minus 4. That's negative 5 over negative 14. A negative divided by a negative is a positive. That means all the values over here are positive values. All of these are positive values. Whether I put a negative 6 in or a negative 7 in or negative 8 in, those are all going to be positive values. I can also test something in that interval. Something between negative 5 and 4, I go to the easy one, 0. 0 is between those. Let's plug 0 into this equation. If I plug a 0 in, I'll have 5 over negative 4, which is a negative number. That means all of these values between negative 5 and 4, they're all negative values. After 4, plug something in bigger than 4, like, I don't know, 10. If I plug a 10 into each of those, I'll have 15 over 10 minus 4 is 6. That's a positive number. So all of these inputs, all of these x's more than 4, are going to lead me to a positive result. The reason that's important is I was wondering about when this equation was going to be less than or equal to 0. Well, when it's less than or equal to 0, that's when my values are negative. It's only going to happen over this interval. Then all you need to do is decide whether to include the negative 5 and the positive 4. In this case, we are definitely going to include the negative 5 because that's where my function's equal to 0, right? That'd be 0 in the numerator. 0 divided by something other than 0 is 0. But I'm not going to include the 4 because that's where I'm undefined. And being undefined is not the same as being equal to 0. So this expression is negative or less than 0, less than or equal to 0, anytime between negative 5 and 4, including negative 5, not including 4. All right, that's it. One more chapter to go. I'll see you in the next video.